high in exercise SYS-5. We are to investigate influence of the gearbox type on the overall drivetrain performances, such performances as efficiency, weight and cost. As you maybe know, in some industries there are typical combinations of gearbox which are popular. For example, in wind turbine industry, the combination of stages where we have two planetary stages and one helical stage is quite ordinary combination. Also for conveyors, the use of worm gears in combination with some other stages is also quite typical. So in this exercise we also should pay special attention on efficiency, especially efficiencies at partial loads, which, as you may know, are lower than the rated efficiencies. And the efficiency of the overall drivetrain is a product of efficiencies of its components. So let's try first the wind turbine drivetrain, and we use the gearbox, of course, because all the exercise is about the gearboxes. So we set up the parameters as required in the specification, and of course we need to correct the voltage level to the one we need. And now let's try the gearbox. So now by default it is one-stage gearbox, but we would like to try three-stage gearbox. The first two stages will be planetary and the last third stage remain helical as it is by default. So we see the motor is in place and the frequency converter is possible to choose. So we take the wall-mounted version here as the simplest, and we go to report, and here we can read up the efficiencies both at rated, at partial loads, both efficiency of the overall system and the components. So now if we go back, we may want to try a different motor type. The gear ratio is quite high and the speed at the gear output is quite high, so we can use induction machine. And again we choose this wall-mounted frequency converter and go back to the report, click on show report, and here we see the different numbers, of course, for the machine and the overall system. So efficiency of the induction machine is of course lower than that of the permanent magnet machine, so overall efficiency will be lower as well. But the gear efficiency both at the rated load and partial load will be the same. We can go back again and try the system with two stages, two planetaries as it was in the exercise, and try permanent magnet machine and some other solutions as well. So now let's work with the conveyor. First we set up the parameters according to the spec and we check voltage. Yes, it is 400 volts as we wanted. And now let's try gearbox. So let's try worm gearbox. It has very high gear ratios compared to other gearbox types, from 10 to 14 DriveConstructor. Here we should be careful choosing some ratio which allows us to get motor chosen from our catalogs. So in this case it worked. So we have both the motor and the frequency converter chosen properly. But now if we go to show report, we also can see the parameters of the system, like efficiencies at partial loads, and you see they are much lower than for other gearbox types. Worm gears have quite poor efficiency, especially at partial loads. But now if we wanted to add some stage to this worm stage, it doesn't work. It is blocked in DriveConstructor because in real life you usually do not start with worm stage in the gearbox. So if we wanted two helical stages, for example, we choose it like that and play with the ratios as we want to try to optimize the system. So this is exactly how it happens in real life. Thank you for watching.